Hello everyone, Dennis here. In this video, I'm going to discuss with you GC O-Level Physics October-November 2019 paper 1. The subject code is 6091. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Alright, let's start discussing the paper. For every question, after I have finished reading the question, I will give you 5 seconds to think about the answer. If you need more time to think about the answer, feel free to pause the video. Okay, now for question 1. Which quantity does not have a unit? A. Refractive index, B. Resistance, C. Volume, or D. Wavelength. The answer is A. Refractive index. The SI unit for resistance is ohms. The SI unit for volume is meter cube or symbol meter cube. Wavelength is meter. For refractive index, the formula is N equals sine I over sine R, and it does not have a unit. Question 2. The labeled arrows in the diagram represents the directions and sizes of the forces acting on a stationary point mass. In which direction does the point pass accelerate? So here is the diagram A, B, C, D. The answer is B. To determine the answer, first we need to look at these two forces, which is the 6 newtons and the 3 newtons. Since both forces are pointing at the opposite directions, hence the resultant force will be 6 minus 3, which is 3 newtons. Then these 3 newtons will act with another 3 newtons pointing to the left, which is from the original diagram, and let's determine the resultant force. So we use the tip to tail method to determine the resultant force. So here is the direction of the resultant force F. Hence the answer is B. So if you want to know the value of this force, we can apply Pythagoras theorem, which is F equals square root of 3 square plus 3 square, which is square root of 18 newtons. Question 3. Which row shows whether mass and speed are scalar or vector quantities? So option A, both mass and speed are scalar quantities. Option B, the mass is a scalar quantity while the speed is a vector quantity. Or option C, the mass is a vector quantity and the speed is a scalar quantity. Or option D, both mass and speed are vector quantities. The answer is A. Both mass and the speed are scalar quantities. Recall that scalar quantities are quantities that have magnitude only, while vector quantities are quantities that have both magnitude and direction. Since mass and speed do not have direction, hence they are scalar quantities. Question 4. The diagram shows a micrometer scale. Which reading is shown? A. 5.64 millimeters, B. 7.14 millimeters, C. 7.16 millimeters, or D. 7.64 millimeters. The answer is D. 7.64 millimeters. So to take the reading, first we need to look at the main scale or the sleeve scale. So from here we can see this is 5, this scale is 6, and this scale is 7. We also can see that there is one scale at the bottom, which is 7.5. Next, we look at the scale line, which is aligned to the timber scale. From here, we can see that the value is positive 0.14. Hence, the reading will be 7.5 plus 0.14, which gives us 7.64 millimeters. Question 5. The velocity time graph for a car is shown. What is the acceleration of the car at 30 seconds? A. 0. B. 25 over 50 meters per second square. C. 25 minus 5 over 30 meters per second square. Or D. 25 over 30 meters per second square. The answer is A. 0. So recall that acceleration is the gradient of a velocity time graph. Hence, we look at the time 30 seconds. It is at the maximum point. Hence, the gradient equals to 0, which means that the acceleration is 0. Question 6. A heavy object is dropped from an aeroplane. The velocity of the object is measured at 2 points before it hits the ground. The velocities are found to be the same. What is the explanation for this? A. All objects fall at constant velocity. B. The force on the object due to air resistance is equal to the acceleration of free fall g. The force on the object due to air resistance is equal to the object's weight. D. The force on the object due to air resistance is larger than the object's weight. The answer is C. The force on the object due to air resistance is equal to the object's weight. So here is the keyword. The velocities are found to be the same. So we know that acceleration formula A equals V minus U over T. Since V equals to U, then acceleration will be 0. Based on Newton's second law, F equals ma. Since acceleration is 0, then F will be equals to 0. So this F is the resultant force. So when an object with a certain mass is free falling, there are two forces acting on it. The first force will be its weight, W. The second force will be the air resistance. So F, or the resultant force for this free falling object, will be W minus the air resistance. So since F is 0, then the weight will be equals to the air resistance. Hence, the answer is C. Question 7. What is the order of magnitude for the diameter of the Earth and for the diameter of an atom? Here are the choices. A. The diameter of the Earth is 10 gigameters and the diameter of an atom is 0.1 micrometer. Or B. 10 gigameters, 0.1 nanometers. Or C. 10 megameters, 0.1 micrometer. Or D. 10 megameters and 0.1 nanometer. The answer is C. 10 megameters for the diameter of the Earth and 0.1 micrometer for the diameter of an atom. Here is the fact check. The diameter of an atom is about 0.1 to 0.5 nanometers. On the other hand, the diameter of the Earth is 12,742 kilometers, which is 12,742,000 meters, or it is about 13 megameters. So among the four choices, C will be the correct answer. Question 8. A car has a mass of 800 kilograms. The car's engine exerts a driving force of 2,500 newtons on it. This causes the car to accelerate at 2.0 meters per second square. What is the total resistive force acting on the car? A. 900 newtons. B. 1,600 newtons. C. 2,100 newtons. Or D. 4,100 newtons. The answer is A. 900 newtons. To get the answer, let's draw the free body diagram. So this is the car, and the mass of the car is 800 kilograms. It has a driving force of 2,500 newtons pointing to the right. It accelerates at 2.0 meters per second square. So we need to find the resistive force pointing to the left. So based on this free body diagram, the resultant force will be the driving force minus the resistive force. Based on Newton's second law, F equals to ma. So this F is the resultant force, hence the driving force minus the resistive force will be equals to ma. Now we need to find the resistive force, which is the driving force minus ma, and now we substitute the values. We'll get 2,500 minus 800 times 2.0, and we calculate, we'll get the answer is 900 newtons. Question 9. Which statement concerning the mass of a body is not correct? A. The body experiences a force in a gravitational field because of its mass. B. The mass is a measure of the amount of matter in the body. C. The mass changes when the strength of a gravitational field changes. Or D. The mass resists a change in the state of rest or motion of the body. The answer is C. The mass changes when the strength of a gravitational field changes. Option B is the definition of mass, which is a measure of the amount of matter in the body. Hence, it will not be affected by the strength of a gravitational field. For option A, the body experiences a force in a gravitational field because of its mass, so this force is called the weight of the object. For D, the mass resists a change in the state of rest or motion of the body, so this resistance is called the inertia. Question 10. A brick of mass 8.0 kilograms rests on one of its flat surfaces on the ground, as shown in this diagram. The gravitational field strength G is 10 newtons per kg. What is the minimum pressure it can exert on the ground? A. 0.40 Pascal. B. 400 Pascal. C. 4,000 Pascal. Or D. 40,000 Pascal. The answer is C. 4,000 Pascal. To calculate the pressure, first we need to determine the weight of the brick using the formula W equals mg. So the mass is 8 kg and the g is 10. Hence 8.0 times 10 will get 80 newtons. Next, to calculate the pressure, the formula is P equals F over A. Now to get the minimum pressure, the A has to be maximum, and the force for this case will be the weight of the brick. So, based on the diagram, this surface will be the largest surface. Now, we substitute the value, the W we have calculated, which is 80 newtons, and the largest surface will be 0.1 times 0.2. Then we calculate, we will get 4,000 Pascal. So this is the minimum pressure that the brick can exert on the ground. Question 11. Given this diagram, two vessels are joined together with a tube and filled with water. Both vessels are open at the top. How does the water pressure at point R compare to the water pressures at point P and Q? So here are the choices. A. Pressure at R is greater than at P and lower than at Q. Or B. Pressure at R is greater than at P and same as at Q. Or C. Pressure at R is same as at P and lower than at Q. Or D. Pressure at R is same as at P and same as at Q. The answer is B. Pressure at R is greater than at P and same as at Q. So how do we get the answer? Remember that for pressure of liquid, to calculate the pressure, formula is P equals to rho GH, where rho is the density of the liquid, G is the gravitational field acceleration, and the H is the height of the liquid. So, pressures of liquid at the same liquid level are the same. The pressure of liquid at a point is higher than the pressure of liquid at a point above it. Therefore, the answer is B. Pressure at R is greater than at P and same as at Q, as both the point P and Q, Q and R are at the same level, while point P is above them. Question 12. A uniform tube sealed at one end is held vertically with the closed end at the top, as shown in this diagram. It contains a thread of mercury which traps a column of air. The other end of the tube is open to the atmosphere. The pressure due to the thread of mercury of height h is 0.18 times 10 to the power 5 Pascal, and the atmospheric pressure is 1.0 times 10 to the power 5 Pascal. What is the pressure of the trapped air? A. 0.18 times 10 to the power 5 Pascal. B. 0.82 times 10 to the power 5 Pascal. Or C. 1.0 times 10 to the power 5 Pascal. Or D. 1.18 times 10 to the power 5 Pascal. The answer is B. 0.82 times 10 to the power 5 Pascal. Now to get this answer, first we need to form the equation correctly. So from the diagram, we can see that the pressure of trapped air plus the pressure of mercury, where both pressures are pointing downwards, equals to the pressure of atmosphere, which is pointing upwards. So that the pressure will be in the equilibrium state, and hence the mercury will be trapped in the tube. So rearrange this equation, we can see that the pressure of trapped air equals to the pressure of atmosphere minus the pressure of mercury. Then substitute the values. 1.0 times 10 to the power 5 minus 0.18 times 10 to the power 5, we get 0.82 times 10 to the power 5 Pascal. Question 13. Electric cars use electric motors instead of combustion engines. The electric motor can be used as a generator to charge the car's battery. What are the energy conversions involved in this process? A. Thermal, kinetic to electrical. B. Thermal to electrical to chemical. C. Kinetic to thermal to electrical. Or D. Kinetic to electrical to chemical. The answer is D. Kinetic to electrical to chemical. To get this answer, let's look at this simple diagram. So for the electric cars, we start with the electric motor. It is connected to the battery of the car. So when the electric motor turns by the wheels of the car, the kinetic energy is converted to the electrical energy. And this energy is stored in the battery in the form of chemical energy. Hence, the answer is D, from kinetic to electrical to chemical. Question 14. An object is initially at rest. The object is dropped from a 50 meters high tower. Air resistance can be ignored. Assume that the potential energy of the object is zero when it is on the ground. What is the ratio of the kinetic energy of the object to its potential energy at a height of 10 meters from the ground? A. 5 to 4, B. 2 to 1, C. 4 to 1, or D. 5 to 1. The answer is C. 4 to 1. To get this answer, first we know that the gravitational potential energy formula is mgh. So for this object, it is at certain height and initially it is at rest. So let's label the mass as m since we don't know the value of the mass. So the distance from this object to the ground is 50 meters. And then it drops to the height of 10 meters. Now, the GPE when it is at 50 meters will be m times 10 times 50, which will get 500 m joules. When it is at 10 meters, then the GPE will be m times 10 times 10, which is 100 m joules. So, the kinetic energy when it is at 10 meters will be GPE loss. To calculate the GPE loss, we'll take the GPE at 50 meters minus the GPE at 10 meters. Hence, it will be 500 m minus 100 m, which get us 400 m joules. Now, we want to get the ratio of the kinetic energy to the potential energy, which is 400 m to 100 m. And we simplify this ratio, it becomes 4 to 1. Hence, the answer is C, 4 to 1. Question 15. A lorry is traveling at a steady speed along an expressway. The force is 3,600 Newton and the power produced is 90,000 joules per second. How far does the lorry travel in 1 minute? A. 1.5 meters, B. 1,500 meters, C. 90 kilometers, or D. 5,400 kilometers. The answer is B. 1,500 meters. To get this answer, we need to use two formulas. The first formula is the work done, which is equals to the force applied F times if the distance traveled in the same direction with the force D. The second formula that we need to use is the power formula, which is P equals to energy E divided by the time T. When we rearrange this equation, the energy E will be equals to the power P multiplied with the time T. And the question states that the lorry is traveling at a steady speed, which means that work done is not used to overcome friction. Hence, the work done will be equals to the energy. Then we substitute the formula F times D equals to P times T. So we need to find the distance. We make D the subject. It becomes D equals to P times T over the F. Next, we substitute the values given. P is 90,000, times if the time 60 seconds, because 1 minute equals 60 seconds, and divided by the force applied, which is 3600. If we calculate, we'll get 1500 meters. Question 16. Brownian motion can be observed by the behavior of smoke particles in a smoke cell. What is this evidence for? A. Air is a poor conductor. B. Air molecules are moving. C. Air molecules have more mass than smoke particles. Or D. Convection occurs in air. The answer is B. Air molecules are moving. So this question asks about what does Brownian motion prove? Recall what is Brownian motion. So Brownian motion proves that air molecules move in continuous random directions and haphazard or zigzag manner. It also proves that air molecules move faster when temperature increases. Therefore, the answer for this question is B. Air molecules are moving. Question 17. A partially inflated balloon is placed inside a bell jar, as shown in this figure. The bell jar is connected to an air pump. The air pump is switched on and air is pumped into the bell jar. The pressure in the bell jar is increased. What happens to the pressure and to the volume of the gas inside the balloon? Here are the choices. A. Pressure decreases and volume decreases. B. Pressure decreases and the volume increases. C. Pressure increases and the volume decreases. Or D. Pressure increases and volume increases. The answer is C. Pressure increases and the volume decreases. To explain this, let's recall the pressure of gas. When we talk about the pressure of gas, we can consider the factors that affect the pressure of gas. There are three factors to consider, which are the temperature T, the volume V, and the pressure of gas P. So here is how these three quantities affect each other. The temperature T is directly proportional to the volume V when the pressure P is constant. The temperature and the pressure is proportional to each other when the V is constant, and the pressure is inversely proportional to the volume when T is constant. For this case, when the pressure in the bell jar is increased, then the balloon will be squeezed and hence the volume decreases. When the volume decreases, then the pressure inside the balloon will increase. Therefore, the answer is C. Pressure increases and volume decreases. Question 18. The temperature of a gas is increased. Which property of the gas must also increase? A. Volume. B. Pressure. C. Density. Or D. Internal energy. The answer is D. Internal energy. So this question also related to the concept that we have discussed in question 17. So from here, as you can see, when the temperature changes, the volume doesn't necessarily has to increase or has to change as well, because it can be constant. Similarly, for the pressure, it can be also constant when the temperature changes. Therefore, A and B are not the answer. For the density, let's look at the formula of the density. Rho equals to m over v, where m is the mass and the v is the volume. So since volume doesn't necessarily has to be increased when the temperature increases, hence the density may not change as well. Therefore, the answer is the D, in internal energy. For internal energy, there are two types. One is the kinetic energy, where it changes with the temperature. And the second is the potential energy, where it changes when the matter changes state. Therefore, when the temperature increases, kinetic energy, which is also internal energy, increases. Question 19. Question 19. A block of copper is at room temperature. Which row describes a smaller block of copper at the same temperature? Here are the choices. A. Internal energy is less, heat capacity is less, and specific heat capacity is the same. B. Internal energy is less, heat capacity is the same, and specific heat capacity is less. C. Internal energy is same, heat capacity is less, and specific heat capacity is the same. D. Internal energy same, heat capacity is same, and specific heat capacity is the same as well. The answer is A. Internal energy is less, heat capacity is less, and specific heat capacity is the same. So, the formula for specific heat capacity is C equals to Q over M delta T, where Q is the thermal energy, M is the mass, and delta T is the change of the temperature. The unit for specific heat capacity is joules per kg per degree Celsius. So from here, you can see that it is about how much heat is involved per 1 degree Celsius and per 1 kg. Hence, it will be the same. For heat capacity, the formula will be capital C equals to M times small letter c, where capital C is the heat capacity, M is for the mass, small letter c is the specific heat capacity, and the unit will be joules per degree Celsius. As you can see from here, it is affected by the mass. Hence, when it is a smaller block, the heat capacity will be less. For internal energy, as mentioned previous in question 17, they are kinetic energy and potential energy. So, it will be affected by the mass of the block as well. When it has higher mass, the internal energy will be high. When the mass is small, the internal energy will be less. Therefore, the answer is A. Question 20. A room is heated using an electric heater at floor level. Which statement about convection in the air is correct? A. Heated air becomes less dense and sinks. B. Heated air becomes less dense and rises. C. Heated air becomes more dense and sinks. Or D. Heated air becomes more dense and rises. The answer is B. Heated air becomes less dense and rises. Always remember that hot air rises and cool air sinks. Why hot air rises? Because the density of hot air is less than the density of cool air. Hence it rises and the cool air sinks. Question 21. A girl measures the resistance of a metal wire at the ice point and at the steam point. She records her results. Here is the table showing the results. What is the temperature when the resistance of the wire is 14 ohms? A. Negative 20 degrees Celsius. B. Negative 17 degrees Celsius. C. 17 degrees Celsius. Or D. 20 degrees Celsius. The answer is A. Negative 20 degrees Celsius. So from the record that she has in this table, the ice point temperature is at 0 degrees Celsius. The steam point, the temperature is at 100 degrees Celsius. So we want to find the temperature at 14 ohms. Let's label this temperature as theta. So we know that the resistance and the temperature changes linearly. So let's draw the number line here. So at 0 degrees Celsius, the resistance is 15 ohms. When temperature is 100 degrees Celsius, the resistance is 20 ohms. So what is the temperature when the resistance is at 14 ohms? So from here, we know that they are proportional to each other. Then we can use this formula. The change of temperature 1 over the change of resistance 1 equals to the change of temperature number 2 over the change of resistance 2. So this is the change of temperature 1. And this is the change of resistance 1. So let's plug in the values into the equation. 100 minus 0 over 20 minus 15. So this is the change of temperature 2, and this is the change of resistance 2. So let's plug in the value 0 minus theta over 15 minus 14. Then we solve this equation. We'll get negative theta equals 100 over 5, which means theta equals to negative 20 degrees Celsius. Question 22. Equal masses of oil and water are heated to 90 degrees Celsius and allowed to cool. Which statement explains why the oil cools faster than the water? A. Oil has a higher boiling point than water. B. Oil has a lower melting point than water. C. Oil has a lower specific latent heat than water. Or D. Oil has a lower specific heat capacity than water. The answer is D. Oil has a lower specific heat capacity than water. Let's recall what is specific heat capacity. The definition is the amount of thermal energy required to raise the temperature of a substance by 1 degree Celsius. When a substance with a lower specific heat capacity requires less energy to change its temperature. So which means that it heats up and cools down more quickly. Question 23. A boat oscillates vertically as a water wave passes. The graph shows how the displacement of the boat from its equilibrium position varies with time. Which characteristics of the wave can be deduced from this graph? A. Its amplitude is 2.0 meters and its speed is 0.40 meters per second. B. Its amplitude is 2.0 meters and its frequency is 0.050 Hz. C. Its wavelength is 20 meters and its speed is 0.40 meters per second. Or D. Its wavelength is 20 meters and its frequency is 0.050 Hz. The answer is B. Its amplitude is 2.0 meters and its frequency is 0.050 Hz. So here is how we measure the amplitude. From the graph, we can see that the amplitude is 2.0 meters. Okay, so we measure from the equilibrium position to the highest point. So this is the amplitude. Next, this is how we measure the period. So this is one complete wave. And from the graph, we can see that the period T is 20 seconds. Hence, frequency F is 1 over T, which is 1 over 20, and we'll get 0.050 Hz. Therefore, answer is B. Amplitude is 2.0 meters and the frequency is 0.050 Hz. Question 24. A metal plate is oscillating up and down continuously. In 4.0 milliseconds, it moves from the bottom position to the top position. The oscillation of the plate causes sound waves to be generated in the surrounding air. Sound travels at a speed of 340 meters per second. What is the wavelength of these sound waves? A. 0.37 meters, B. 0.74 meters, C. 1.4 meters, or D. 2.7 meters. The answer is D. 2.7 meters. So to understand the question, let's draw the displacement time graph. Given that in 4.0 milliseconds, the metal plate moves from the bottom position to the top position, we can label it in the waveform. So here is the bottom to the top position, and the time is 4.0 milliseconds. In other words, here is another 4.0 milliseconds. So the period will be 2 times of 4, which is 8.0 milliseconds. From here, we can calculate the frequency, which is 1 over 8.0 times 10 to the power of negative 3, and we'll get 125 Hertz. And using the waveform formula, V equals to F lambda, we can determine the wavelength, which is lambda equals to V over F. Given the speed is 340 meters per second and the frequency we have determined for the wave, which is 125, therefore the wavelength will be 2.72 meters. Answer is D, 2.7 meters. Question 25. A ray of light is incident on a horizontal plane mirror as shown. The light is reflected straight back the way it came. The mirror is tilted through an angle of 10 degrees. What is now the angle between the incident ray and reflected ray? A. 5 degrees, B. 10 degrees, C. 15 degrees, or D. 20 degrees. The answer is D. 20 degrees. Here is how we determine the answer. So originally, the plane mirror is in a horizontal position. So now we tilted it 10 degrees. So here is 10 degrees from the original position. And now we can determine the normal. Originally, it is in this position and it also rotates 10 degrees. So this is the reflected ray and this is the angle of reflection. We know that the angle of reflection is equal to the angle of incident. Therefore, it is also 10 degrees. And now we want to measure the angle between the incident ray and reflected ray. So from here, we can see that the angle is 20 degrees. Question 26. Light travels from one medium towards a less dense medium. It is refracted along the boundary between the media as shown. Which angle is the critical angle? Is it angle A, which is the angle between the normal and the horizontal boundary? Or B, the angle between the incident ray and the refracted ray? Or is it angle C, the angle between incident ray and the normal at this region? Or is it option D, the angle between the incident ray and the horizontal boundary at this site? Okay, the answer is C, the angle measured between the incident ray and the normal. Okay, so this is how we measure the critical angle when the incident ray moves towards the boundary and is refracted along the horizontal boundary. So this will be the critical angle. Question 27. An object is placed in front of a thin converging lens at position X, as shown in this diagram. The distance between the center of the lens and the point F is in the focal length as shown. The object is then moved towards the lens from position X to position Y. Which row describes the images formed with the object placed at the position X and position Y? So is it option A, image with object at X is inverted, image with object at Y is inverted, or B, inverted upright, or C, upright inverted, or D, upright upright? The answer is B. Image with object at X is inverted and image with object at Y is upright. Let's draw the ray diagram to determine the answer. So when the object is at position X, so this is how the ray diagram look like. What we need to do is we draw the focal point here, same distance with this one. So this is the focal length from here to here. So for the converging lens, it is same as from here to here, the focal length. Okay, so once we have drawn this focal length, now we draw the ray. First, we draw the horizontal ray touching the converging lens and then refracted and pass through the focal point. And then second ray, it will start from this point all the way to the center of the converging lens, and it will not refract. It will continue to move in a straight line until, as you can see, these two rays, they will intercept at one point. Now let's extend the horizontal line here, and we can draw the image. As you can see from here, the characteristics of the image formed when object is at X is where the U is between the F and 2F. So the U means that the distance between the object and the lens is between the focal length and 2 times of the focal length. So how is it? First, it is a real image, okay, where if you place a screen, we can form an image. And it is inverted, so it is upside down, so the object is pointing up and the image is pointing down. Next, it is also magnified. So as you can see, the image size is larger than the object. Okay, so then this is 2F. If this is F, this is 2F. Now we want to measure the distance between the image to the lens. Okay, as you can see, the V, which is the distance between the image and the lens, is more than 2F. Okay, now let's draw the ray diagram when the object is at position Y. So here is the object at position Y, and here is the focal length at another side of the lens. So again, first we draw this ray and this ray, where when the horizontal ray pass through the converging lens, it will be bent towards the focal point. And another ray, when it passes through the center of the lens, it will not be refracted, it will just continue to move in a straight line. Okay, so once we have completed these two rays, now let's extend the ray. So as you can see at the right hand side, it is not possible for these two rays to intercept with each other. So we need to extend the ray at this position. Okay, so first this is this ray. Right, we draw the dotted line because this ray does not exist, and then another ray from here to here. Okay, as you can see, these two dotted lines intercept at this point. Okay, which means that the image is formed at here. Okay, as you can see from here, right, we talk about the characteristics of image formed when the object is at Y. Okay, first, the distance between the object and the lens is U, which is less than F. Okay, so once you identify where is the position of the object, then we can determine the characteristics of the image. Okay, the first point is it is virtual because this image does not exist which means that if I place a screen here, I can't form any image here. Okay, next one, it is upright. Okay, so the object is pointing up, the image is also pointing up, so hence it is upright. Next, it is magnified. Okay, the size of the image is larger than the size of the object. Okay, and the image is also behind the object. Question 28. A glass prism has angles of 45 degrees, 90 degrees and 45 degrees, as shown in this diagram. The critical angle for glass is 42 degrees. A narrow beam of light is directed on the prism. Which arrangement makes the beam undergo total internal reflection twice before any light leaves the prism? So here are the four choices: A, B, C and D. The answer is A. To explain why the answer is option A, let's complete the ray diagram for this diagram. Okay, so as you can see, this ray, it is perpendicular to the boundary of the prism. Okay, since it is perpendicular to the boundary, it will just continue to move in a straight line. Okay, and from here we can draw normal at this position. Okay, as we know, this is 45 degrees and this is 90 degrees. This will be 45 degrees, which means this is also 45 degrees. Okay, so the critical angle is 42 degrees. Since this incident angle is greater than the critical angle, hence it will have the total internal reflection. Hence the ray will bend into this direction. Okay, once it hits to another boundary here, okay, first this is 45 degrees and then we can draw the normal here. Okay, so this is also 45 degrees, okay, because this is what we call is the alternate angle, right? So this line is parallel to this line. So if this 45 degrees, this is also 45 degrees. So if this 45 degrees, this is also 45 degrees. Now from here again, this is the incident angle for this ray. Okay, it is larger than the critical angle, which is 42 degrees. Hence, it will have the total internal reflection. Okay, so if this happens, that means the reflected angle also will be 45 degrees. Okay, from here again, when it touch this boundary, it will become 90 degrees. Hence, it will now move straight line and leave this glass away. Okay, so from here, the answer will be A. You can try with other option, and you'll find that option A will be the only answer. Question 29. A teacher has two identical plastic pens. They are both rubbed with identical cloths. The first pen is balanced on an insulated support as shown. The balanced pen rotates when the cloth or the second pen are held near it. Which statement is correct? A. Both the cloth and the second pen attract the balanced pen. B. Both the cloth and the second pen repel the balanced pen. C. The cloth attracts the balanced pen and the second pen repels the balanced pen. Or D. The cloth repels the balanced pen and the second pen attracts the balanced pen. The answer is C. The cloth attracts the balanced pen and the second pen repels the balanced pen. So here is the explanation. Since both pens are rubbed with identical cloths, both pens have the same charges, which means both pens repel each other. After rubbing, the cloth either loses electrons or gains electrons, which means that it has opposite charges with the pen. Therefore, it attracts the pen. Question 30. A negatively charged copper sphere rests on an insulating mat, as shown in this diagram. A negatively charged polythene rod is brought near to the copper sphere. Which diagram shows the charge distribution on the sphere? Is it option A, option B, option C, or option D? The answer is option D. Okay, so first, option A is not correct because as you can see, when the negatively charged polythene rod is placed near the sphere, all the negative charges are repelled to the side here, the right hand side. Okay, but there is no positive charges at the left hand side. Okay, so meaning that there are additional negative charges which is not possible because the polythene rod does not touch the sphere. It is not possible to transfer the negative charges to the sphere. Okay, now for B, even though as we can see, right, the negative charges are repelled at another side, but the number of negative charges is the same as the number of negative charges before the rod is placed near to the sphere. Okay, so they should have more negative charges because some negative charges are repelled from the left hand side. Okay, for C, this is not possible because the negative charges are not repelled by the negatively charged polythene rod. Okay, we know that like charges repelled. Okay, only option D is correct. As you can see, some negative charges are repelled by the rod and then they move to the right hand side of the sphere, so we have more negative charges and left with the positive charges at the left hand side. Hence answer is D. Question 31. Which statement about electric current is correct? A. It is the rate of flow of charge and its unit is the ampere. B. It is the rate of flow of charge and its unit is the coulomb. C. It is the rate of flow of electrons and its unit is the ampere. Or D. It is the rate of flow of electrons and its unit is the coulomb. The answer is A. It is the rate of flow of charge and its unit is the ampere. Recall the current definition, which is the rate of flow of charge. The formula to calculate current is I equals Q over T, and the SI unit is ampere. Question 32. The diagram shows how the current in a semiconductor diode varies as the potential difference PD across it increases from 0. What is the resistance of the diode between P and Q, and how does it change as the PD increases from Q? Here are a few choices. A. Resistance between P and Q is very large, and resistance after Q decreases. B. Resistance between P and Q is very large, and the resistance after Q increases. C. Resistance between P and Q is 0, and resistance after Q decreases. D. Resistance between P and Q is 0, and resistance after Q increases. The answer is A. Resistance between P and Q is very large and resistance after Q decreases. Notice that this graph is current versus PD graph. So the gradient is telling us the inverse of the resistance. Okay, so as you can see, between P and Q it is a horizontal line, which means that the resistance is very large. Alright, so as you can see after Q, when we increase a little bit the potential difference, the current can flow a lot. Okay, so this tells us that the resistance is very low after Q, and for between P and Q, the resistance is very large. Question 33. Voltage current readings were obtained for different electrical components. which readings are for a 3 volts 0.06 amps torch lamp. So here's the reading for option A, the reading for option B, reading for option C, and reading for option D. The answer is B. Right, so if we want to plot the current voltage graph for each of the option, so this is how it look like for option A, and this is how it look like for option B, option C, and option D. You might be wondering why not it is option C, because this is the Ohm's law where the current is directly proportional to the voltage. So you need to understand that this is the torchlight lamp case where the lamp is a filament lamp. Okay, so it does not follow the Ohm's law. As you can see from here, when the voltage increases, the rate of change of the current decreases over here. Okay, the reason is because the larger the voltage, then the hotter the filament. So when the filament gets hotter, the resistance is higher. Therefore, the rate of change of the current will become slower. Hence, the answer will be B. Question 34. The diagram shows an old vacuum cleaner with a metal case and plastic wheels. The plug of the vacuum cleaner is incorrectly wired as shown. What is the effect of using the plug wired this way? A. The fuse in the plug blows. B. The metal case becomes live. C. The vacuum cleaner catches fire. Or D. The vacuum cleaner does not work. The answer is B. The metal case becomes live. Right? The reason for this answer is because, as you can see from this diagram, the earth wire is connected with the live wire, and the earth wire also connected to the metal case, right, to prevent excessive current from flowing, and then we have the potential hazard of electric shock. Okay, so since it is connected with live wire, the metal case also will become live. Question 35. A student set up the circuit shown. What is the current I1 and what is the potential difference V2? Here are a few options. Option A, I1 is 0 amps, V2 is 4.0 volts. Option B, I1 is 0 amps, V2 is 8.0 volts. Option C, I1 is 4.0 amps and V2 is 4.0 volts. Or option D, I1 is 4.0 amps and V2 is 8.0 volts. The answer is D. I1 is 4.0 amps and V2 is 8.0 volts. So here's how we get the answer. From the circuit, we can say that V1 equals to V2 plus V3. So let's study the circuit. So V1 measures the potential difference across the voltage source here, which is the battery. Okay, V2 measures the potential difference for this lamp. V3 measures the potential difference between these two lamps which are connected in parallel. Okay, so these three lamps are passive component. The cells here are the active component. Hence, the voltage supplied by the active components will be equal to the voltage taken by the passive components. So V1 will be equal to V2 plus V3. Then what we need to do is we just rearrange this equation to calculate V2, which is equal to V1 minus V3. So substitute the values. V12 minus 4.0 will get 8 volts for V2. Then to get current I1, so first we start with the I2 here. So this is the reading of this ammeter which measures the current flowing in this conductor.
Okay, so the current will continue to flow in this direction, pass through the first lamp, and then come to this node. It will start to split into the two branches and then collect back into this node. So the current will flow back into this conductor and go back to the source and pass to I1, which is the emitter, and this emitter takes the reading of the current flowing in this conductor. Alright, as you can see from this circuit, the current I1 will be equals to the current I2. Hence, the I1 will be 4.0 amps. You might be wondering if there is any current flowing into the voltage here, and the voltmeter here, and also the voltmeter here. Okay, especially the voltmeter here. So, do take note that current will not flow into the voltmeter because the voltmeter is open circuit internally. On the other hand, current will flow through emitter because emitter is short circuit internally. Question 36. Question 36. The diagram shows the magnetic field surrounding a wire PQ. Wire PQ is a current carrying conductor connected to a direct current DC power supply. What is the direction of the magnetic field and what happens to the field lines when the current in wire PQ is reduced? So here are a few choices. For option A, magnetic field direction is anticlockwise. Spacing of magnetic field lines when current is reduced decreases. Or option B, magnetic field direction is anticlockwise while spacing of magnetic field lines increases. Option C, magnetic field direction is clockwise and spacing of magnetic field lines decreases. Option D, magnetic field direction is clockwise while spacing of magnetic field lines increases. The answer is D. Magnetic field direction is clockwise and spacing of magnetic field lines increases. Now, to determine the direction of the magnetic field, first we need to look at where the current flows. From the diagram, current flows from the positive terminal and flows towards the negative terminal. Then we can use the right hand grip rule to determine the direction of the magnetic field. So what we need to do is the thumb will point towards the direction of the current flow, and then the four fingers will show you the direction of the magnetic field. As you can see from here, it is clockwise direction. For the spacing of magnetic field lines, when current is reduced, remember that the stronger the magnetic field, the closer the magnetic field lines. And on the other hand, the weaker the magnetic field, the further the magnetic field lines apart. So the answer will be D. No. Question 37. The diagram shows the north pole of a magnet move into and out of a coil of wire. This movement produces a current in the coil of wire. The current produces a magnetic pole at X. Which pole is produced at X when the magnet is moving and when it is moved out? So here are a few options. Option A, magnet moving, it is no pole. Magnet move out is no pole. Option B, north-south. Option C, south-north. Or option D, south-south. The answer is B. When magnet move in, X is north pole. When magnet move out, X is south pole. So to obtain this answer, we need to relate it to the Lenz's law, where Lenz's law states that the direction of the induced EMF opposes the change that causes it. So as you can see from the diagram, when the magnet is moving in, okay, so the induced EMF here will oppose it, hence it has to be a north pole, so that we know that like poles will repel. So when the magnet moves up, then this side will have to be a south pole, so that it will oppose the direction, as we know that unlike poles will attract. Hence the answer is B. Question 38. A cathode ray oscilloscope CRO is connected to an AC generator. A trace is seen on the screen of the cathode ray oscilloscope as shown in this diagram. The speed of rotation of the generator is doubled. What is the effect on the trace? So here are a few options. Option A, number of peaks on the screen doubled. The amplitude of trace on the screen also doubled. Or B, doubled, same. C, same, doubled. Or D, same, same. The answer is the number of peaks on the screen doubled and the amplitude of trace on the screen doubled as well. So what is the reason? This is because increasing the rotational speed of an AC generator directly increases the output voltage and frequency. Okay, why? Because the rate of change of magnetic flux linkage, which determines the induced electromotive force EMF, is directly proportional to the generator's speed. Hence, the number of peaks on the screen doubled and the amplitude of trace on the screen doubled when the speed of rotation of the generator is doubled. Question 39. Which material is used for the core of a transformer and what is the reason? Here are the options. Option A, the material is copper because it is a good conductor of electricity. Or option B, the material is copper because it is easy to magnetize and demagnetize. Option C, the material is iron because it is a good conductor of electricity. Or option D, the material is iron because it is easy to magnetize and demagnetize. Okay, the answer is D. The material is iron because it is easy to magnetize and demagnetize. Okay, so we usually use the soft iron core to build a transformer. Okay, we don't choose copper because it is not easy to magnetize or demagnetize. Hence the answer is D. Question 40, the last question. Electric power cables transmit electrical energy over large distances using high voltage alternating current. What are the advantages of using a high voltage and of using an alternating current? So here are the options. Option A, advantage of using high voltage is because high current is produced in the cable, and the advantage of using alternating current is because the resistance of the cable is reduced. Or option B, because of high current is produced in the cables and the voltage can be changed using a transformer. Or C, less energy is wasted in the cables and the resistance of the cables is reduced. Or option D, less energy is wasted in the cable and the voltage can be changed using a transformer. The answer is D. The advantage of using high voltage is because less energy is wasted in the cables due to a high voltage, low current, hence the resistance is low. Okay, when resistance is low, then energy is less wasted. Okay, and the advantage of using alternating current is because we can change the voltage using a transformer. So as we can raise the voltage using step-up transformer and reduce the voltage using a step-down transformer. Therefore, The answer is D.
Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Support me. If my videos benefit you in your learning, you can treat me a cup of coffee. To do this, link is at the description area. Until then, see you in the next video. Have a great day ahead and all the best.